Hi everyone, I hope all of you are doing well. In today's session, we will learn about DNS, which stands for Domain Name System, and the DNS architecture, need of DNS, its working, and troubleshooting. So I hope you will enjoy the video. So keep watching with us. So the first topic is, let's start with why we need DNS. What is the need of having DNS? Why it is necessary? So I will try to make a point here with the help of two situations. So let's imagine a world without DNS first. So if anyone is trying to access any website on the browser, let's say CNN.com or Facebook.com, in that case, what is www.cnn.com or facebook.com? How the internet will know what that website is all about and how to access that? Because internet only can communicate or create a connection knowing the source and destination IP address. And that we have already learned in our previous session where we have talked about the OSI models and the transport layer in that, even the TCP IP model. All the reference model gives us that clear picture what the network learns about. So networking helps us to communicate between source and destination, and that is how from the browser we can access the cnn.com. So we need different other information as well, like IP address, port. In this situation, the browser is unaware of the IP address. How it will reach cnn.com? What is it? Browser is unaware about that. In the second case, if I say, if any human being say I can memorize the IP address, so in that case he tried to directly access the website on that particular IP address. So my question would be, can you memorize all IPs, all the IP address available there? A single website like facebook.com or cnn.com can be sitting behind a lot of IP addresses, and you might be getting only single IP address towards the load balancer, which is further load balancing your request to your nearest IP address available, or the server which is providing you the web page response. So in that case, how we can memorize all the IPs? So in these two situations, in order to answer these, we came up with the concept of DNS. So now DNS helps us to provide direct mapping from the domain to the IP address. So we do not need to anymore memorize any IP address of the websites, and even if the browser is accessing, browser will reach out to the DNS, the domain name server, and it's going to respond back with the IP address information, so that we can easily route on a particular network and hop by hop directly access the server on the internet. So that is the need of DNS. So next, let's try to understand the DNS architecture, how the DNS architecture looks like. So in this situation, let's consider there are three different machines present who want to access the DNS, who wants the DNS. Every machine, in order to access a particular thing on internet, will need DNS, because we just discussed, if we want to access any website or any application on the internet, we need to get the public IP address for it. And how we can get? DNS is the place. DNS is the book which keeps the records and entries for domain to IP address mapping. Now from PC1, if a particular user try to access cnn.com in this case, then it's going to also check on certain places for the DNS cache. If the cache is present at any place, like browser cache, then the router level cache, on the operating system cache, if it's going to check if it has that DNS mapping available from domain to IP address. If not, in that case, it's going to route the request to the DNS resolver. On the user level machine, so on the machine level, it can be the private IP address offered by the DHCP server to that particular machine. The request will be routed towards that private IP DNS server, and further it will be sent to the ISP DNS resolver, which can be common and be shared between PC1, PC2 and PC3. So if all these three different users are raising a request to three different websites, in this case PC1 is reaching out to cnn.com, PC2 is reaching out to facebook.com, PC3 is reaching out to instagram.com. So in that case, these three requests for the very first time will be sent to the DNS resolver, and that DNS resolver is going to further reach out to different levels which are present in the DNS architecture in order to fetch that information. Now in the DNS architecture, first level is the root name server. So root name server is there are only I would say 26 root name servers available. 13 are for the IPv4 public IP addresses and 13 for the IPv6 addresses. Now once someone have accessed www.cnn.com, the request reaches DNS resolver. It will be sent to the root name server. It's going to see what is the root here. So after .com, there is again a dot at the end, which we normally do not see in the browsers while accessing the websites. But that is where, so it is going to start the parsing of the website from the right to left. We are now going from right to left. Normally we write the websites while typing, we go from left to right, but now parsing happens right to left. So at the end we see a dot which we might not see in the browser. That is the root name server. So everything is connected with the root name server. The first request will reach to the root name server. Root name server is going to see what is the root after the dot, that is the top level domain, which is com here in our case. So COM, where this COM is present. So first of all, root name server is going to look for entire website, whether it is present in any cache on the root name server or not. If it is not present in the cache, it's going to look at the top level domain information, which is com here, .com. Now root name server does not know about the .com. It's going to provide that information back with the location, which is going to be a reference location where you can further search for .com domains. So now root name server is going to respond back to the ISP DNS resolver. ISP DNS resolver now knows from the response where I need to search next for that .com domain, top level domain. Now it is going to reach out to the top level domain name server, which have that .com information. Now .com further it's going to parse it towards the left, sorry. Now from .com it's going to read the cnn.com now. So where is this domain present? cnn.com. Now if it is present in the cache, top level domain is going to give response back to the DNS resolver. If not, it's going to again give a reference location for the cnn.com. Now once it respond back to the DNS resolver with the reference location, DNS resolver is going to further reach out to the authoritative name server in order to search for the cnn.com mapping with an IP address. And authoritative name server is something which is always maintained by the domain selling websites. Taking an example here of GoDaddy. So GoDaddy, once anyone purchases a domain from any domain selling websites like GoDaddy, it's the responsibility of the domain provider to make sure the authoritative name server will be updated with the public IP address and domain mapping in the future. So now authoritative name server will definitely have the result of cnn.com mapped with its public IP address, which it is going to return back to the ISP DNS resolver. Once we have the public IP mapping with the cnn.com, it's going to again get cached at each level. First, it is going to reach at DNS resolver, it will be cached. Further, it will be sent to the PC which have requested it. In our case, PC1 requested for CNN.com IP address. Now IP address is first cached on the DNS resolver, then it will be cached on the PC1 browser as well. So in future, now this architecture is very helpful. And what is the major role of caching here? Now if in future PC2 request again for CNN.com, it does not need to follow the entire path, entire hierarchy here. It will just reach out to the DNS resolver. It already have the cache for the CNN.com. It's going to directly provide the IP address. And that is how the DNS work.